Now, what we do now is to figure out how the AP exam for field response is written. So here you go. This is one problem. These are the combination between multiple concepts that we covered so far. So if you forget the theory, you may be able to refresh the concept on the left hand side right here, which is like, first we're gonna have to use the Newton law of motion and use a free body diagram of frictionless surface. Friction surface, we use the torque that. And what we're missing right here is the conservation of energy. So these are the step ones that we need to be able to figure out what that is right here. So for now, so instead of showing you how I would derive from here to here, I would just, for example, let's look at what we're doing. Because the first and second video, I've already derived the equations to solve for certain thing. So the question right now is, are we trying to figure out what object to use? Are we using So for this one, I'm just gonna go ahead and use the cylinders. So I'm just gonna say is cylinders initial is equal to 1/2 mass times radius square. Okay, for that one. So I'm just gonna say for cylinders, we're using so once we replace that one, the final one should be mgh is equal to, this one I combine is 3/4 mv square. So to figure out what that would be the velocity at the bottom of the ramp. It will be 4/3 times gravity times the height. And basically what this is, it is confirmed to be velocity in OX. So now we've done solving the first problem. So second step, use kinematic equation to solve for the time. So I'm just gonna use this one. But the velocity always is equal to 0 because there's no objects moving up and down. So it will be this equal to this plus 1/2 g t squared. So now we're gonna solve for t. So that would be the time it takes will be 2 times change of the height divided by gravity. And then we follow step 3. Use the time calculate in step 2. So to solve for the distance in the x direction, we use this equation, Vox times time. So Vox is that one. So I'm just gonna go ahead and replace 4/3 times height, that's velocity in the x directions. My y is equal to 2 delta y divided by gravity. So I'm just gonna go ahead and simplify this one. So let's not simplify, let's do it like this, and then you will have to problem solve using number. And then for the last part of the project, so we're gonna have to utilize the concept of this one right here, which is at rest, and the ball is moving and dropping with velocity Vox. So Pi is equal to Pf. Pi is equal to, I'm just gonna say mass. Okay, mass M1 is the cylinder mass. M2 is the cart. So that would be M1 times 4/3 that. So it's one velocity final. So to solve for final velocity, it would be M. I noticed that they have a lot of things going on here, but you're gonna have to like bear with me in order for us to solve for the equations. I actually boxed the answers so that you know the final velocity of both of the cylinders and the cart are moving to the right, because the key word right here is that it sticks together.